Today's lesson is on factoring by greatest common factor, grouping, and binomials. So factoring is the rewriting of an expression to be the product of two expressions. For example, 15 we can rewrite as 3 times 5. So therefore 3 and 5 are both factors of 15. 15 was rewritten as a product of two other numbers. So x squared minus 9 can be rewritten as x plus 3 and x minus 3. If we distribute, we do truly get x squared minus 9. Now I don't expect you to know how to do that right now, but we know that this is true. So therefore we can say that x plus 3 and x minus 3 are factors of x squared minus 9. We will teach you how to factor x squared minus 9 a little bit later on in this lesson, but I just wanted you to understand that if you take a expression and if it can be rewritten as two other expressions being multiplied, that those two expressions that are being multiplied are called factors of the original polynomial, and when it says to factor, you're trying to rewrite your expression as the product of two expressions. Now, there are many types of polynomials which require different methods of factoring. As I teach you each method, I'll tell you when you're able to use each method. You will need to be able to factor all types of polynomials, so we need to learn many methods. Our first method that we're going to talk about today is greatest common factor, or for short we call it GCF. So the greatest common factor, or GCF, is the largest or greatest number or expression that will divide all of the terms. Note that when you're factoring out a variable, you should factor out the variable to the lowest power. If the leading coefficient is negative, then you always factor out a negative from the whole polynomial. So when do you want to use GCF? Well, I want you to always try this method first. Now let's practice factoring out the GCS of the following polynomials. Our first example is 8x squared plus 18xy plus 2x. So I want you to look through all of the numbers, the coefficients 8, 18, and 2. What can 8, 18, and 2 all be divided by? Well, the largest number that they can all be divided by is 2. 8 can be divided by 2, 18 can be divided by 2, and 2 can be divided by 2. There is no other larger number that works, so this is the greatest common factor of all of the coefficients. Now we need to look at the variables. In the first term I have x squared, that's 2x's being multiplied. On the second term I have xy, and the third term I just have x. Which variable is common between all three terms? And the answer there is x. So when I factor out a 2x, what I'm going to be doing is basically dividing each term by 2x. Because when it says to factor, I want to rewrite as the product. So if I've already determined who the first term that we're factoring out, the GCF, I need to find out what it multiplies by to get the original polynomial. In order to do that, the operation is division. 8x squared divided by 2x is 4x. Then it says plus, so I put a plus. 18xy divided by 2x. 18 divided by 2 is 9. xy divided by x, well, the x's divide out to 1, and I'm just left with y. Plus 2x divided by 2x. Well, 2 divided by 2 is 1. Now, in this case, I have to write the 1 because I don't have anything else after it, so I have to have at least a 1 there. Now, if I find out that there's more terms after it, I can go back and erase the 1, but for now, let's leave the 1. So 2 divided by 2 is 1. X divided by x is also 1. Do I need to put another multiply by 1 there? Well, not really, because I already have a 1, so 1 times 1 is still 1. It doesn't really help me there. A lot of students will forget this 1, or they just won't put it at all. But if you start off with 1, 2, 3 terms, then you should have 1, 2, 3 terms inside your parentheses after you factored out a GCF. That way, if you're trying to check your work and you distribute through, 2x times 4x is 8x squared. This is my check, okay? 2x times 9y is 18xy. And then 2x times 1 is 2x. If you didn't put that 1 there, then you would have not got that third term, which is necessary. Now, is this equal to the original problem? Yes. So I know my boxed answer is truly the factorization of 8x squared plus 18xy plus 2x. Let's do this again. On my next problem, I have 14, 21, and 28 as my coefficients. What can 14, 21, and 28 all be divided by? And I think the largest answer there is 7. Next, I'm looking at the x's. I have x cubed, x squared, and x to the fourth. Now, what can all of those be divided by? That might be a little bit difficult for you to think about, but up in the instructions, I suggested that if you're ever trying to factor out a variable, you should factor out the variable to the smallest power shown. So each term truly does have x's, so we know that there can be x's factored out, but the smallest power here is 2. That means each of them can truly be divided by x squared. This first term has 3 x's, I can take 2 of those out. The second term has 2 x's, I can take 2 of those out. And the third term has 4 x's, and I can take 2 of those out. So basically I'm taking out 2 x's from each term. Alright, let's go back and divide. 14 divided by 7 is 2. X cubed divided by x squared. X cubed divided by x squared, I'm subtracting the exponents and just getting x to the 1, or just x really. 21 divided by 7 is 3. Notice the minus comes down with it because I'm not factoring in a negative. And then we have x squared divided by x squared. I had 2 x's, I factored out 2 x's, I'm not left with any x's left, and x squared divided by x squared is 1, so I don't need to write it. And the reason I don't need to write it, because if I wrote multiply by 1, 3 times 1 is still 3. Now, if there wasn't already a 3 here, then I would need to put my 1 there. But because there's already a 3, multiplying by 1 isn't really going to change it. 28 divided by 7 is 4. X to the 4 divided by x squared. Subtract my exponents and I just get x squared. This is my factorization. Now, this work down here you may not need to show, and that's fine. If you don't need it, you don't have to have it. If you're interested, I'm going to show you one more time the check, but then I'm not going to show you on every single problem. So 7x squared times 2x is 14x cubed. 7x squared times negative 3, that's negative 21x squared. And the last one, 7x squared times 4x squared is positive 28x to the fourth. Is that equal to the top polynomial? It sure is. So I know that I've done my answer, and that's correct. Now I'm not going to continue to show you the check, but you're welcome to check it, your answers anytime you would like. On the next problem, we start with a negative. Now because we start with a negative, I am asking you in the instructions above, if the leading coefficient is negative, then I want you to factor out a negative from the whole polynomial. If the first term is ever negative, I really want you to factor out this negative. It's going to make it a lot easier later when we learn more methods. So the coefficient then could come out of 7, 35, and 14. The greatest common factor there would be 7 again. Just looking at the x's, x to the 4, x to the 2, and x to the 2, looks like the lowest exponent is x to the 2. And then looking at the y's, y squared, and y to the 5th, there is a y in all of them, and the lowest exponent common is just y to the invisible 1. So then I go back and divide. Now be careful with the negative. A negative 7 divided by negative 7 is a positive 1. Now I'm going to put a 1 there because there's nothing else behind the 1 at this moment, but once there is, I can go back and erase the 1. X to the 4th divided by x squared, that leaves me with x squared. At this moment, I could go back and erase the 1 if I really wanted to. I don't necessarily have to have the 1 there, once there is terms behind it. And then y divided by y is 1. Do I need to write 1 now? Well, no, I just erased the 1. I didn't need that 1 there because there is already another term. Okay, next term, negative 35 divided by negative 7. Negative divided by negative is a positive. 35 divided by 7 is 5. X squared divided by x squared is 1. I don't need to write it because I already have the 5 there. y squared divided by y is just y. Next term, negative 14 divided by negative 7 is positive 2. X squared divided by x squared is 1. I don't need to write it because I already have a 2 there. Y to the 5 divided by y is y to the 4. This is the factorization. I can look inside the parentheses between x squared, 5y, and 2y to the 4th and see that there's nothing else common, so I know that I've completely factored.